Good day, everyone. I welcome you back to Global Education Zone, the home of impactful learning. It's nice over here for you and I because learning never ends and education is the key to an impactful life. Good day, everyone. My name is Anthony Nathaniel. I welcome you once again to Global Education Zone. And today, in this particular episode, we are going to be doing a revision exercise on all the things I've been teaching so far. So, this is how it goes. It is more like a do-it-yourself exercise. So, I will give some questions and then you try to solve it. You pause the video and try to solve them. Then when you are done, you continue playing the video and then you watch out the solution on the board. So that's what I'm going to do here. So I'm going to solve basically 4 questions. So the first one I'll be solving today is going to be the simultaneous linear and simultaneous quadratic equation. Now you will recall that in a previous episode of this mathematics for SS2, we talked about how simultaneous equations can be solved by elimination substitution method and how you can involve a quadratic equation in a simultaneous equation. So that is what we'll be doing today, and take down the question just in case you want to solve it. So number one, that's the first question for this class. That's the first equation is x plus y equals 3. Then the second equation is 2x squared plus y squared equals 54. So now this is the first question, and now you can pause this video to try to solve it, but this is the solution. Now this will be your equation 1 and this will be your equation 2. Now in this equation 1 and equation 2, you are going to try to make one of these variables. You are going to try to make them the subject of the equation. So for the simultaneous linear equation, you are going to pick the linear of the two. So this is the first one is the linear because the highest powers of the unknown is 1. So the linear equation always has the highest power as 1. But this is the quadratic because it has the highest power of the unknowns as 2. So it has a degree of 2 rather. So if you have it like this x squared, it has a degree of 2. So that's if at least one of the terms has a degree of 2, it will be a quadratic equation. So even if it's a product of x and y, it will still be a second degree equation of both. So but it's just combined together. So whether you see it as x squared or you see it as y squared or you see it as xy, those are all terms that denote second degree equations and they are quadratic. So if you are still not sure what I'm saying, go and check out the episode on simultaneous linear and quadratic equation in this course, this mathematics for SS2, and then you will see that I've explained all about the solving simultaneous equations and with a lot of revisions. So now today let's talk about, first of all, you go to the linear equation, you make any one of the unknowns your subject. So now I'll pick x. I want to make x my subject this time around. So I'll say, okay, in the first equation x plus y equals 3, right? Now let's make x the subject. So x equals what? 3 minus y. Now, when you make x the subject, you are going to substitute that value of x into the second equation. So that will be 2x. Instead of writing x now, we'll put 3 minus y because we have said x equals 3 minus y. So simply substitute the value of 3 minus y for x in equation 2, which is the quadratic equation. So 2 open brackets, 3 minus y squared plus y squared equals 54. Now we're going to expand the bracket and open it. Now, whenever you have the square of a bracket term like this, so two terms, when you have the square of two linear terms in a bracket, when you have the square of two linear terms, yes, in a bracket. Now, yes, you can use that squaring formula. So it's open at, that will be 2 open brackets. This will be the square of the first term plus 2 times the product of the terms plus the square of the second term. So this is how it works. So now the first term is 9, so the square of the first term is 3, so the square of the first term will be 9. So this is a shortcut for opening a bracket. So what I'm trying to say is that if you have anything like a plus b squared, that would be equals to a squared plus 2ab plus b squared. So this is one shortcut. You don't really need to start expanding everything and so on and so forth. So you can just make use of this shortcut. So that's what I'm trying to say. Now we're going to make use of this shortcut. And that will be 2 open brackets. A is 9, so a squared will be a is 3, so a squared will be 9 plus 2ab, 2 times 3 times minus y, that's minus 6y. Then lastly we have b squared. B squared is minus y, so 2 times minus y is so minus y squared is plus y squared. Then plus y square equals 54. So then we have when we expand the bracket by multiplying through by 2, we have 18 minus 12y plus 2y squared plus y squared equals 54. So now let's collect like terms and simplify. So 2y squared plus y squared, that's 3y squared minus 2y plus minus 12y plus so okay, rather 3y squared minus 12y plus 18 equals 54. When we move this when we subtract 54 from both sides, we will have 3y squared minus 12y. 18 minus 54 becomes minus 36 equals 0. So far, we can divide through by 3. That will leave us with y squared minus 4y minus 12 equals 0. Now, what remains is for us to factorize this equation. So we are simply going to look for two terms that whose product will give us the product of the first and last, and whose sum will give us the middle term. So obviously this should be minus 6 and 2. So then we have y squared minus 6y plus 2y minus 12 equals 0. So factorizing y open bracket y minus 6 plus 2 y minus 6 equals 0. So consider y minus 6 multiplied by y plus 2 will give the solution. So that means y equals 6 or y equals minus 2. Now, as a job for you can use these values of y to substitute in this equation where x is equal to 3 minus y, and you are going to look for the corresponding value of x. So now, when y is 6, x is 3 minus y. That means x will be 3 minus 6. That's what? Minus 3. So let's represent the answer as ordered pairs. So x is minus 3. When y is 6, x is minus 3, and y is 6. So when y is minus 2, x is 3 minus minus 2. That's 5. So when y is minus 2, x is 5. So this is the order pair of the order pair solution. So these are 2 points. These 2 points they correspond to the intersection of these two equations when they are represented on a graph. So it's simple enough like that. Now, in a particular episode, we'll talk about linear inequalities, right? Now, these linear inequalities, they are not very difficult to understand. So I'm going to be solving something on linear inequalities right now. And this part on linear inequalities is quite simple, not very difficult. So we have to express in the inequality x plus 2 is lesser than 10 is lesser than x plus 17 in the form a is lesser than x is lesser than b, where a and b are integers. So we have to express this x plus 2 is lesser than 10 is lesser than x plus 17. But I'm going to express it in the form of a lesser than x lesser than b, where a and b are integers, and we're also going to sketch it on a number line. So now, whenever you see 2 or more inequality signs like this, when you have this lesser than sign is connecting x plus 2 lesser than 10 lesser than x plus 17. Now the first thing is you do it in 2 steps. The first step, we're going to solve the first two connected inequality. So that's this and this. So x plus 2, that was step 1. X plus 2 is lesser than 10. So that means let's subtract 2 from both sides. So x is lesser than 8, and that would be the solution of the first step. Let's go on to the second step. For the second step, we'll look for the last two. That will be 10 and x plus 17. So 10 is lesser than x plus 17. So that means when we subtract 17 for both sides, we have minus 7 is lesser than x. So now we have something like this. Now we can also if minus 7 is lesser than x, that means x will be what? Greater than minus 7. So that's how it means. So it's just like if I'm older than you, then you are younger than me. So that's what it means. So if minus 7 is lesser than x, that means x is greater than minus 7. Just simple logic. Now we are going to combine these two statements together and express it in the form of a lesser than x lesser than b. So now if x is greater than minus 7, so that means minus 7 is lesser than x. So let's write it again. Minus 7 is lesser than x. Yeah. then and x is lesser than 8. So and this x again is also lesser than 8. So in this form, we have expressed in this form of a lesser than x lesser than b, and our a here is -7, our b is x. Sorry, is 8. So that's -7 lesser than x lesser than 8 is the solution of this question, and then we have to sketch it on a number line. So if we were to do that, we'll just draw a number line, the sketch of a number line. This will be our 0 point. Let's take it in intervals of 2, -2, -4, -6, -8, +2, 4, 6, 8. Yeah. So these integers that do not have sign before them, they are also positive. So if I say +2 or 2, they are still positive. +2 still means 2. So now -7 lesser than x. So let's look for the points for this integer point. So this is -7. We have a circle on top, and then yes, this is 8 here. So we're going to connect them together as the region satisfied. So the reason why I will not shade the interior of these circles, because there's no lesser than or equals to. So it's simply lesser than and lesser than. So even if it was -7 lesser than or equals to x, I would shade this. If it was x lesser than or equals to 8, I would shade it. But since it's just -7 lesser than x lesser than 8, so these circles will not be shaded. So take note of that. It's very easy to mistake. So now this is the region represented by this solution, and that is the solution of the question. Now the third question for this video will be to sketch the graph of the inequality 5x over 6 is greater than or equals to 10. So we are going to sketch the graph of this. This is the third question for this question. So we are going to sketch the graph of 5x over 6 is greater than or equals to 10. So now here we are trying to sketch the graph of this, right? So now this is going to be represented by a line. So now let's multiply both sides by 6. That means 5x will be greater than or equals to 60 if we multiply both sides by 6. Now let's divide both sides by 5. Now I told you earlier on that inequalities, you also multiply and divide both sides just like equations. You pretend as if they are equations, but you still respect them for their inequalities. Now that will be x is greater than or equals to 12. Now, and just in case I haven't mentioned this, one time you divide an inequality by a negative number, you reverse the direction of the inequality sign. So if we divide this by -5, now this greater than or equals to will change to the opposite sign, which is lesser than or equals to. So that's a very simple logic. Now if x is greater than or equals to 12, let's represent that on the line. So if this is our Cartesian plane and this is the x if this is the x abscissa and this is the ordinate, this abscissa now will be x. So we'll point to the 12. Let's assume this is x. So we'll draw a line for this, the line x is equals to 12. Now an equation is a line, while an inequality is a region. So now we don't need the line, we need the region. Yeah, we need the region that's represented by when x is greater than or equals to 12. So that means if x is greater than or equals to 12, let's check let's test the origin. So when x is 0, that means 0 is greater than or equals to 12. Is that true? That's not true. So that means the region that is not containing the origin is what we will shade. So we shade the region away from the origin. So this region to the right is what satisfies this inequality. So that is the region represented by the inequality 5x over 6 is greater than or equals to 10. Now I was stating earlier that if you divide both sides of an inequality, you reverse the sign. So let me demonstrate that here with this last question. So we are asked that 8 minus 5x is lesser than or equals to 3. We have to solve that. So when you have 8, okay, that's visible. 8 minus 5x is lesser than or equals to 3. So now let's subtract 8 from both sides. That means minus 5x is lesser than or equals to 3 minus 8, which is minus 5. Now we have minus 5x is lesser than or equals to minus 5. Now what we'll do next is we are going to divide both sides by the coefficient of x, which is minus 5. So we divide both sides of the inequality by minus 5 by minus 5. So minus 5 cancels out on the left hand side, which x. So now, and on the right hand side, minus 5 divided by minus 5 is what? 1. So but in this inequality, when we divide both sides of an inequality by a negative number, the inequality will change sign. So instead of having x, instead of having the lesser than or equals to, we'll be having the greater than or equals to. So that means x is greater than or equals to 1 will be the solution. So that's what I mean by when you divide by a negative sign, you change the sign. And even when you multiply by a negative sign, you also change the sign. When you multiply or divide, because yes, when you multiply or divide, you change the sign. So that's as far as I can go on this video on revisions and do it yourself exercises. So hopefully I'll see you in the next episode of this course. Thank you for watching.